Hey everyone. Well, two people. Is my mic working?
Hi. Hi, Dan.
Hi. Hey, how's it going?
Hi, everyone.
Okay. It may be a shorter meeting today with not too many people showing up, but I did make quite a bit of progress on what we talked about last time. So I kind of wanted to walk through. Hey, Lou. I kind of wanted to walk through what I've come up with, and what I think I'll be posting it tomorrow. Finally, rebasing the TSM core tree on latest and picking up all these fixes. And changes. But the biggest thing is, for your use case, De, am I pronouncing it right? Deshaun? Deshaun?
Yeah, Deshaun.
Deshaun.
Yeah.
Okay. Um, is what I worked through on some of the trust framework pieces, and um, also has a question. I also have a question for you, Luna, about it because but let me just walk through that, and we can um, see if anything else comes up. People have other concerns. Um, but besides walking through the device trust proposal as it is, anybody else have any other opens things they wanted to talk about? And if not, I will share this over here. Let's see. Um, this patch is device trust. Okay, so I mean the concept is pretty simple, but it raises a lot of questions. Um, but I think it can support the use case of a bus provider wanting to specify the trust level. So it's just a it is just a um, it's just an enum attached to the struct device, um, and so the um, the idea is the idea at least to start is that you can specify that a device has no trust at all, and then you can set the trust level via a module parameter to say by default nothing binds, drivers don't attach, but then you can specify, you can force the driver to attach by basically by a command line option. So that's just kind of the first level of don't operate drivers unless the driver says you can by default. Where this actually gets set up is in let's see, paste. So what I'm thinking is in device add time, the the bus, the device will get its trust initialized by the bus is responsible for initializing the trust value. And so before device add, the expectation is your trust level is established. If the bus doesn't set up the trust level, then it can set a default. So this is where that none would come in, and that's so that's where your default trust would come in. But otherwise, the bus is responsible for setting up the trust. So if the bus can set up and that happens before device add, then I think for your use case, the simplest place, and I think it's pretty easy to defend, is that every time the PCI bus adds a device, it calls back to the controller and says, "Hey, controller, do you have anything else? Do you want to set the trust level before this device becomes active?"
Okay.
So I think that would be something like a device add callback to as part of the PCI ops that your bus that your controller or bus provides.
Then do you mean the bus driver should answer the question of the initial trust level?
Yeah. That the bus driver can set the trust before, and if it doesn't set it, then you can fall back to a default. But otherwise, it's up to the bus to set the trust level before the device is added.
Okay.
Go ahead.
Did you add a purpose op or something?
I don't add a per bus ops. Okay, so the idea that especially because well, I'll take a look at this. So one of the things that start converting is that this PCI untrusted flag moves from the PCI device to be just this new trust level, this adversarial trust level. When a device is in that mode, it does two things. At IOMMU probe time, it sets up the default IMU domain to be the DMA domain, like the same as the PCI untrusted flag. And then at DMA configure time, it turns off ACS blocking or leaves ATS translation blocking turned on if the device is untrusted. Yeah, so the expectation is that that we can set the trust level before the device is added, and that the new trust level we're going to add is that the device can be in the TCB at the beginning of time. And so the expectation, though, is that the trust level can change, or the trust level is not actually finalized until you bind the driver, or until you go through the bus's DMA configure step. So that's where I'm planning to add the actual considering what the trust level is and changing settings. So if the device is saying I'm in the TCB trust level, then that is when it will either just trust it. Because I'm assuming in the case of the paravisor, there's nothing that's going to say no to the device being trusted. It's basically just the bus knows best, and the bus can say I trust this device, and there's no callback. For the normal confidential computing case, when we want to actually enable DMA and actually enter the device into the TCB, that's when we need to validate the evidence and say, okay, we basically need to call the enable DMA step for whatever the confidential computing architecture needs. So for ARM CCA, we need to pass back the digest of the measurements to make sure that to make sure that they match, things like that. So that'll be a callback at the bus DMA configure time to say, hey, this device is a trust level. This device wants to be trusted, and we have a driver that's loaded that says, hey, you cannot. You had better ask me for ask for permission for this, or ask for this device to talk to the TSM and enable DMA before it's enabled. Yeah, I mean, I'll pause there for questions about how that works.
Yeah. So that as we discussed earlier, in my case, there is no parent bridge for the PCI device.
Correct. Yeah.
I'm not sure your package can also handle that scenario.
Well, so I'm expecting that we go ahead like we talked about last time. I think before I was like it was just a proposal, but now I think it was just an idea, but now I think it's actually a proposal, which is modify the PCI bus, the PCI operations, because right now there's an add bus. I think it makes total sense to have an add device callback, and so
Yeah.
And that's where you could say your initial trust up, and just know from there that the device is that device should be treated as if it's in the TCB, and that there is no driver. There's no other driver that's going to be they need to talk to.
Yeah. So do you already add a device callback in your page set?
I did not, but if it would help to show the idea, I can. Like I don't know if so. I'm pretty close to releasing these. I don't know. Yeah, I'm okay to include that as an example, an RFC example of adding that thing, or you can just follow on with your own patch set after that's out.
Yeah, I think I can reply to your commit proposing add a device callback.
Okay, yeah, I will yeah, I'll copy you on that posting, and then yeah, I'll be sure to follow on and kind of see. Yeah, we talked about it. We think this is
Okay. Okay. Sounds great. Thank you.
Yeah.
By the way, so with this page set, is it possible that on the same bus there can be trusted device and untrusted devices?
They can be. The concern would be for like an IOMMU group. So like it's possible you could have an untrusted device and a trusted device in the same group,
Right.
same IOMMU group, but the trusted device would still have to suffer being in the translation to, or it would need to suffer not having access to translation and that kind of thing. But other than that, if you don't have an IOMMU in the way, then you should be able to have
Great.
trusted devices with full performance next to untrusted devices on the same bus.
Okay. So far we do not have a virtual MMU inside the case.
Yeah. So if there's no virtual IOMU, then all the trust level is the only thing a trust level is giving you is whether you map the interface as with the encrypted bit or private memory bit.
Yes.
And that's pretty much it. Yeah. Like so. It would just it basically it's just telling you it's a mapping flag.
Yeah.
Is there I'm curious with these devices, is the assumption that they are 100% private? Like there's no such concept as an interface report, and that the device bar could be partially private, partially shared. That's just not supported, right?
So actually, I'm testing telescope device on AMD Turing blade on Hyper-V, and that device actually has two private PCI bus and one shared PCI bar. And currently, I'm using a hack to map the bar as shared or private. But as I mentioned in the chat, I'm going to I think modify the I think there's a function called AV is MMIO private, which is invoked in the LRMAP kernel API. So I think I'm going to use that to solve the private or shared DMA mapping issue.
Okay, I wonder if this would help. So, because one of the things we're doing in the, like what we do in the in computational computing case is, oh, no, sorry. And maybe you could do this too, but like, so when we get the interface report,
Yeah.
in the new patches, we're going to insert them into this sideband resource tree. And then IRV map, when you say, hey, IRV map this PCI bar, the idea is that we don't need to modify any drivers. But I think your Hyper-V bus could, if it knows where all the if it knows where all the shared resources are for a device, it could inject them in here. We could use the same mechanism.
Oh, but the TSM driver is not used at all in my VM.
Yeah, the TSM driver is not used at all, but like but nothing stops you from populating. This is a global.
Oh, I see. I see.
It lives right next to the other ones, IOMM and other ones in the comments.
I see.
So, I mean, that might be a mechanism we could share, which is either this tree either gets populated by the interface report and the TSM driver, or it gets populated by a bus and knows.
Okay. Okay. But this increased LRAM resources is not exported. It means it cannot.
Not exported. I mean, yeah, like I have no problem exporting it, but like is a Hyper-V driver a modular built in?
We have some built-in part of the code. So yeah, I mean, yeah, we can have some built-in code to access this data structure.
Yeah, I mean, I don't think it's a big deal to export it, but yeah, if the built-in part of Hyper-V can do it, then that's I guess that's better. I mean,
Okay.
the idea is that the IRV map is built in, PCI core is built in, but yeah, like so, but yeah, I don't see a big problem exporting it if you absolutely need to.
Okay, thanks. I will look into this.
Okay. So that's coming. But the other between device trust and that getting set up at DMA configure time, and maybe having a device add callback that you're going to add. The other one is yeah, this interface report thing. This is maybe more for you, Loon, but I ended up. So I heard through the grapevine that we finally solved the mystery about that this field is not a PFN. It's a full physical address. So
Yeah.
So that change is coming in. The only thing we haven't solved, and I ended up just adding in a parameter for it, is the is the reporting offset bar aligned or not? ARM says it is. I think Alexei says, people say it's not. I don't like this original code. I think came from the TDX code, and I think so. I think TDX code was assuming that it's not aligned. I think you can read the spec either way. I think a reasonable person can read the spec and say, I think it means that every single, at least the first range you report for a bar needs to be either a locked range, a locked MSIX range, or a is non-TEE mem range. Like basically the first range of the bar has to be mapped, and then you know where the bar starts, and off you go.
You mean that the first range of the bar must be reported?
The first range of the bar must be reported.
Must be okay, but do you mean we need to let the PCI SIG to clarify this, or we assume that, because I think this report is produced by the device vendor, is it? So there's no guarantee that.
Well, the report is produced by the device vendor, but the MMIO reporting offset is chosen by the TSM, right?
Yes, yeah. You mean that the TSM firmware should regulate the report, is it?
Yeah, the TSM firmware knows. Yeah, it knows whether it's aligning the MIO reporting offset or not. I haven't seen guidance, like official guidance, published by the other implementations, but ARM did. ARM published theirs, and ARM is doing this. ARM is saying you must assume, and the TSM is going to enforce that the MIO reporting offset is bar aligned. Is basically you have to go. You have to figure out the maximum size of all the bars on the device, and your MIO reporting offset needs to be set to that maximum alignment.
But how do they do that? They make the secure firmware to regulate the report, or what do they do to ensure this?
I don't know how. I don't know how they enforce it, because the only way to figure it out is to ask the VMM to tell you, right? Like so. So, I mean, and if it gets it wrong, then it can figure out that it's wrong, like that the guest didn't get the right expectation. But I'm basically saying I'm trusting what their spec says is that the way you calculate this on ARM is you make the assumption that the offset is always bar aligned, which I think is a fine assumption. It's not.
So this doesn't raise a request for the TDSP spec, is it? It is a request for the firmware spec.
I would love for the PCI SIG to specify it, but at the same time, it's only 2 lines of code, and a parameter. So you pass in the scheme. If you're on CCA, somehow you've managed to make it aligned, and if not, then you can do the other thing. And if your interface report doesn't validate, you can try the other one, and maybe some device get like. There's been so much confusion about this, and it takes so long to get these things fixed that I'm okay to allow because this will be in the PCI core, hard to change, but you can always change your driver to be like, oh hey, for some reason this device came up with the always reporting everything scheme, and it breaks if you do the bar line thing. So just pass it in at this point.
Okay.
But the physical address one was pretty fundamental. But I think that's another reason why I'm not 100% on now that we've gone through that discussion about this needs to be a full physical address. What's the point of having a full physical address if you're going to throw away most of the bits all the time? Because we were like, no, you must that first thing must be all the address bits. Like, okay, that's fine, and then also we need to align it to throw away everything, which is almost always going to be more than 4K. Like by definition, it's always going to be more than 4K. So then that makes me think that people are definitely thinking of having reporting offsets that are not bar aligned to start. So we'll see. Kind of pick your poison, but I mean, but the way I'm reading the spec, like I think I'm now, if you ask my personal opinion, I think the model of at least the first range needs to be mapped, and if it's MSIX, if it's unlocked MSIX, I think it needs to be reported as non-TE mem. I think people are reading the spec as saying you can't report MSIX unless it's locked. Like, no, you can report MSIX. If it's unlocked, then it's not. Then it's just normal non-TE mem. And then everything seems to work. But then everything seems to work, and then you get maximum entropy on your reporting offset.
I didn't get it. No, when you say if the MSIX range is the first range of the bar, then what should we do? We cannot report this MX range. The device cannot report this MX range in the report, is it?
Well, the device cannot report it as MSIX. The interface report can't say it's MSX, locked MSX, because that bit is only for, the way I read the bit is it says you must report it as, you must set this bit if it's an MSX range and it's locked. If it's an MSX range at the start of the bar and it's unlocked, then as far as the interface report is concerned, that's just another non-TMEM range.
Okay. This is it is MSIX bar. It is MSIX range, but it's unlocked. So do we need to report it?
So you only need to report it so that you can calculate the reporting offset. Because if it starts at the beginning of the bar, so if the start of your bar is MSIX,
you must report this MS bar.
You must report it as just another non-TE mem range.
Oh, okay. I know. You don't report it as an MSIX bar. You report it as a normal non-TE range.
Right.
Okay. That needs firmware to maybe regulate this report, is it?
It needs firmware to regulate report. Well, like no, it wouldn't, because you just tell the device when the device is being locked, you tell it don't lock MSIX, and then you ask it to generate the report. Then the device just says, okay, I will generate a report for everything that's unlocked. It doesn't care about MS, like basically it stops caring about MSIX at that point. But yeah, but this is why I keep coming back to, like, reasonable people, I think, could say, no, we did it the ARM way, and no, we did it the other way, and I'm pretty sure at this point, like, it was a diving catch to do this, and we still haven't gotten. Maybe we can go back and quickly get an answer on this one, but for now, it's basically just it can only be one of these two things. We know it's one of these two. Otherwise, we're basically into a mode where you have to like ask the TSM, like, what did you do? So we know it's one of these two things.
Okay. Okay.
But yeah, but I'll send a note to the PCI SIG people and see if they want to clarify this.
Okay.
But yeah, but it might not get clarified, and I don't want to wait. But yeah, that's basically where I'm at. Like, it's been so long since we rebased this tree that I want to get something out, and I wanted to support both, and we can kick that. If the answer comes in time, we can fix it up.
Yes.
Okay, so then the last piece that has that I think has implications for TDX, and you tell me if you think it can handle it or not, is so the trust levels are nothing. Adversary, which is like the old school PCI untrusted flag. This is the normal trust level, which is turn on everything you can all the time. And then this is the one we care about for being able to do DMA and should we map this device MMIO as encrypted. Like I said before, all of this, you can change the trust level right now only either through compile time or runtime with a kind of module parameter.
Okay.
I might also add a per device sysfs flag, but right now it's basically kind of the module either loads as trusted or not, because that's a very easy that already modules are interesting because they already know how to match to devices. Like, so you can write a pretty good policy just based on modules, but that may not be fine-grained enough because you might have multiple instances of a device, and some of them are trusted, some of them are untrusted, and you don't want to set the same policy for all of them. So we'll probably end up with a mechanism to set it on a per device basis. I mean the bus can always set it on a per device basis, but yeah, we might have a administrative way to do it. But anyway, the only time that gets considered for, well, let's say so for Deshwan's case, this doesn't matter because we'll get in here into PCI DMA configure. This runs right before the device binds to the driver. We'll get in here and we'll find out, hey, we don't have a TSM driver. There's nothing to double check if the thing is supposed to be in the TCB. We just trust that the bus got it right. If the bus gets it wrong, there'll be fireworks later, but that's not our problem. So that's the paravisor I know better case. In the confidential computing case, we will notice that hey, this device is locked and accepted or in the run state. Well, actually, it won't be in the run state. I mean, this is a concern. So right now we have the lock and accept sysfs switches. So you echo one to accept the device, and that was doing too much. In one echo you were validating that all the evidence was correct. You were putting the device into the run state, and you were enabling DMA all in one step. And all these conversations I've had with Jason and Greg and other people, like, we want to split that up. And so the accept flag will still ask the device to be put into the run state, which I know CCA and AMD can do, but it won't put, but it will not, at that step, it will not enable DMA. Not until this step, not until the DMA configure step, do we actually check the trust level and try to enable DMA at this point. So this is the point at which the TSM layer can say, no, your evidence is not validated, or no, the measurements you currently have aren't correct. And I think unless it's changed recently, I mean, is it still the case that TDX requires enabled DMA validation before DMA accept before run?
No. It can do the DMA accept after run.
Okay, then we're fine. Then we're good.
Yeah.
Then we're all aligned. Yeah. So that'd be the plan. Is accept is just get you into the run state. You can operate the device without DMA. Like, so basically, you could just use encrypted MMIO if you wanted to, and never enable DMA.
Yeah.
But then if you actually trust the device to enter the TCB and you set this trust level, then this DMA configure callback is where is where it'll figure that out. Yeah. So I think that's pretty much the outcome of everything. I mean, so basically everything we talked about last time, these are kind of the design decisions that fell out from that. And then now that the merge window is over, it's time to start the push for this stuff to get out there. Is that spec released? Or I can go look at it. You learn about the change to the MIO versus DMA enabling.
You mean no, it is this is just pure internal in Intel. I don't think there's a spec released yet.
Okay, but the direction is going that way. Okay.
Yes. I always remember there's a requirement there, and they have several rounds of discussions for security concerns, and they attempt to move the DMA accept before run, but I insist on that, and they finally accept that.
Yeah. First, they have to do the YLUN accept before the DMA accept. Right. Oh, geez. Okay. Sorry, that was a bad joke. But yeah. So I think that's pretty much all I wanted to run through. But I think it going. Oh, I guess the only other thing that came up. So like, I feel like I'm trying to make sure I get everybody's concerns in there at the same time. So the other one thing that's come up is Alistair is working on the CMA thing, which is native evidence gathering for PCI devices, or I mean, well, SPDM in general, but PCI is one of the devices. And for PCI, I said, hey, let's not split up and do different formats and ABIs. Let's just everybody make a TSM driver, and so his TSM driver will just have a connect callback. It won't do any of the TDIS stuff. It won't do IDE. It will just connect to the device and get the certificates, the measurements, and all that good stuff.
It is also like a generic TSM driver for native SPDM. Is that?
Yeah, I mean, so the SPDM protocol itself he has is it can be over any protocol.
Mm.
The but the CMA specific part is just for PCI.
Yeah.
The biggest difference between DMA and TDISP is that TDISP says you can only do TDISP on the function 0 device. But for CMA, you can do it on any device. Like, so you can have multiple devices. They can each have their own DOE. Like it could be a DOE on every function of the device, and each one can do its own authentication. So the only change, and he's like, that doesn't make it fit. It doesn't make the it doesn't fit the model of what the PCI TSM core is doing currently. And so the change there is going to be rename the PF0 stuff also just a TSM host, basically, so that you can, when you don't have IDE, you don't have TDIS, you don't have this kind of multiple functions to manage, you can still basically do the TSM connect flow on any device if your driver supports that kind of thing. If there's a DOE mailbox there for that. So I think it's just a core change, but yeah, it might cause some other patches to rebase.
Do we have some rebase requirement for TSM so Fender TSM patch, Fender TSM drivers?
Well, I mean, so far.
I see. So far, the PCI TSM PF0 is exposed to platform TSM driver, so we need to change it.
Yeah.
Okay.
Yeah.
I know.
But I think it's just a rename for
just a rename. Okay.
For the vendor drivers, and then for the core, it's going to be. I think there's a little bit more work that Shashiko found out. Shashiko says, basically Shashiko's like, hey, when you connect to things that aren't function 0, and then you start walking all the child devices, then things get messed up. Like, so basically the TSM core is going to have to say, if you're not doing TDIS later, then there's nothing else. Then you don't need to walk these subfunctions anymore. But I think that's just a core change that doesn't. I think that shouldn't affect the vendor drivers for this stuff. So yeah, so that's all I wanted to walk through here. I did see. I did see Ackerley joined earlier, and it just reminds me that at some point we're going to start working on mapping like huge pages and other things for devices, and but that's coming up. So that might be a future topic, is when now that GASP MFD is getting in-place conversion going, or I think in-place conversion is a requirement for device assignment, just because it gets really messy if you don't have in-place conversion.
Yeah, this actually here. That's good to know. Working on in-place conversions now, and Sean says it's pretty close to merging. We
Yeah,
are
yeah,
aiming for 7.3.
7.3, yeah. Yeah, no, yeah, that looks really, that was a big journey, so really congratulations on on that work.
Yeah.
Thanks. Wait, so you're saying that compression is going to be required for PCI assignment? Is that something to do with managing private and shared MMIOs?
Yeah, I think because right now we originally had a requirement to have the discard manager in QEMU for device assignment for MMIO management, and yeah, things just get simpler if you can assume that in-place conversion is there. You don't have to use a discard manager for public-private assignment.
Oh, okay. So for MMIO, how do you envision the interaction between like VFIO and guess MMFD to be like?
That I haven't quite gotten to yet, but that's next.
Okay. Oh, so I'm going to be working on huge TLB next, and like the current interface is to have a new flag for huge TLB, a new guess MMFD creation time flag for huge TLB, and I've just been like chatting with a few people about an alternate interface where like perhaps I can get some FD to huge TLB and hand it to guess MMFD so that guess MMFD knows what kind of thing it is wrapping, and then I was thinking that could possibly extend to VFIO, like get a VFIO FD and hand it to Guessman FD. And Guessman FD can wrap it. And so does that sound like it could possibly work?
It sounds like it could possibly work. The it reminds me. Have you been following Gregory Price's work at all on his private node thing? Private memory
no,
node.
not aware.
Yeah, it seems like an interface that you that might be interesting for where you can now basically you can basically get a private allocator in front of any memory range and might be able to do huge page in front of it, but I will. I'll at least point you at his latest proposal because like this whole idea of setting aside memory for private alloc because you basically want to reuse the huge tool BFS allocator for as a guest MMFD backing thing.
Yes.
Gregory Price came out this from the we've always had this device stacks thing and it's been kind of unusable because it turns off a lot of the MM services like especially for CXL memory. But if we could get NUMA like mbind and memory policy stuff in front of CXL memory, but not have that CXL memory leak into other allocations, then it's basically his API is basically a way to do mbind on a file descriptor and have your own kind of private memory space.
Okay.
I'll
take a look.
But yeah, I'll send you a note and see if that looks interesting. Okay.
Okay, thank you.
Thank you. Yeah. But other than that, that's all I have for this week. Any other questions or things that come up before we wrap up? Going once, going twice. If not, I will catch you all at the next one.
Thank you.
Have a look at those patches, Joshua. I think it's a good chance to get them out tomorrow.
Okay. Okay. Thank you.
Okay, see you guys.
Thanks all. Bye.
Bye.